All right, guys, here we go. 1-10 is transformation. Let me hurry explain why I'm giving you guys this. You do have online homework as well tonight. You have both. Just for the fact of the matter, online, a lot of times when they're asking the graph, they make it do multiple choice. I can freaking pick it out a multiple choice fast by okay? It's not really teaching you how to graph. No, so I do have 5 promises so you can do them on your own, right? Because once again, on your test, you will be graphing it by hand. You will be doing multiple choice. So therefore, I needed some way to get you guys to practice. With me? Okay. So that's why you do have this as well. So a lot of times when I believe graphing is important, I will make you guys do online and something via hand as well, okay? So let's talk about some of the parent functions or type of functions you guys have already learned in the past. Give me something. I know something that you guys don't want to do. Would you learn last year a lot? Quadratics is something that you did quite a bit last year, right? So what I'm going to have you guys do is I'm going to have do you I'm going to start a chart. This chart represents parent function. Okay, those are the x values I chose. No reason. The reason why I picked them is notice I have a y-intercept. I have the negative values and some positive values. I call these my fast points. Okay, they work for a lot of graphs. So what's the y value if I have an x value being negative 2? 4. 1. Oh, look, you guys pick it up. Anybody questioning how I have my parent function? That would be the parent function for x squared. What else did you guys learn? We studied what else? The first class isn't talking to me. You guys usually talk. How about a linear? You guys do a linear equation? Sure. Notice it would just be the exact same value, right? You guys want to cubic what? What they look like? What do we use for cubic? So this would be -8, -1, 0, 1, 8. Have you guys learned absolute values in the past? Okay. Should I get that's on you, buddy. You're the one leading class. Hey. It's all on you. What's on you? Oh. Did you just say, can I get help? Sure. More than welcome. That's what your responsibility is. Hold on. Hey, what other where's the value of 4 would be my not. Could I? Yes. 1. I can do this, but I'm not. What's the number of 9's not too bad, right? What's the other one? Notice I picked nice numbers that gave me a perfect square root, right? Could I pick 2? Could I pick 5? Could I pick 7 or 3? Could I? Yeah, whereas the value that the output is nice with these ones. No, does that make sense why I picked these ones? And the last one we're going to do is the cube root of that. So same kind of idea. What do we need? 9 is not. I would need 8. Gives me 2. 1 gives me 1. 0. I'm not going to do 27 for the fact I don't want to do 27 6 months. I have 2 more I'm going to take. How about -1? Cube root of -1 is -1, is it not? How about -8? It's -2. Okay? These are my parent functions. This is where you're going to start today. Any questions on how I got these values? Because it's important that you know how they are. Are you on your phone? Are you one of those people? I think you are. You just were. Still same thing. I don't know how you guys listen to people. I listen to music. I don't know how to. Then people come and tell me I don't get it. And I'm like, hey, it's not saying you have done that. But I do get people. I'm like, you listen to music instead. Here we go. What are we doing? Oh, yeah. Here's the function. You guys have that transformation in the past. So it should be somewhat on a remedial topic. We might get a little deeper. Can anybody tell me how does this shift? Yes, Kimberly. Yeah, which direction is it shifting? 3 to the left is correct. Anybody tell me why, though, I'm moving this 3 to the left? The why, though? You're not giving me the why, though. You're just telling me a rule. Why? What value made this guy 0? This guy, even though we have a +3, the value that makes him 0 is -3. So I'm going to start right now, ladies and gentlemen. I'll show you what I expect you guys for graph. It might be different than what your other teachers do, but the reason why I do it is to make sure that you understand every step of the process. So let's say this is a 2-step process. I have my parent function in one shift. The most you guys could have is 5 items. Okay, so there could be 5 different things to do on one of these graphs. But on this one, it's only 2. Okay, so who's my parent function? What is it going to look like? X squared, right? Does everybody agree with me? So I'm going to have my parent function be x squared. So I start with a table. What is my parent function table? That was the -2, -1, 0, 1, and 2. Do you guys agree with that? So I got these values when I plug them in. Any questions on that? Okay, then I go ahead and do my next part. What's different between here and here? We have a horizontal shift this way. To the right, left, left 3. And the reason why I'm going left 3 is because, notice, that's the new value that gives me it 0, right? Notice I went from 0 to -3, correct? That gives me the value of 0. Does everybody understand what I'm saying by that? Notice the y value is the same, so what did my x values do? We shifted left 3. So what do I have to do with this guy? Shift him which way? Left 3, so he's -5. How about the next one? -4, -2, and -1. What values will come out of this, though, even with this shift? I'll have the same values. Because notice, here's my function. Here's x squared, right? X plus 3 makes me shift 3 to the right. 1, 2, 3. And my y values change at all. Did my arms move up or down at all? No, they stayed the same. What changed? The x values did. Right? You guys remember doing this last year? Okay. So that would be called a horizontal shift. Right? Okay. I'm going to add something to this equation. What would I do if I had this +1 on the outside? Say again. My y values are shifting up 1, aren't they? So notice I'm going from here to here. I don't start at the beginning. I start off what was the previous thing I had, which is this gentleman, correct? I go from here to that guy. And I ask myself, what's different from the middle function to what I'm trying to do now? I am just shifting my
y values up 1. So I keep these x values, right? The x values are staying the same, but what's happening? The y values are shifting up. If you don't believe me, what could we do? That's funny, that almost made me laugh. I can plot in one of these points, can't I? Here we go, let's play -5. -5 plus 3? -2. Look, I'm back at this spot. That's why I went there. 2 squared gives me 4. And then that 4 plus 1 gives me 5. Do I have the accurate point? Did I have to plug anything in to get those? No, I just understood what these shifts are doing to my x and my y values. Okay, you guys will look at your homework. Not that I'm going to do one, but I'm going to talk about it. You look at number 5. That's really not a function. From the fact of the matter, there is a vertical line with it. It's technically not a function. But we're just representing it as some graph, right? We're going to call it a function, but it's really not. Is everybody with me understanding why it's not just a vertical line? But could I do the same stuff? So if I drew this function like such, okay, let's say I had 0, 2, 1, 0, 4, 3, and then 5, -1. Is that a function? That's a real function. I don't know what that is, so I'm just calling him f of x, right? What would I do? That's my parent function, isn't it? Is everybody with me on that? So if I said, okay, what does this do? Tell me everything that does to that graph. What does this do? Sure. It was, yep. So we're going to go right 3. We're going to take this and move it right 3, right? What does this do? It multiplies our y values by 2. It's called a vertical stretch. What does this do? After we stretch it, it moves everything up 1. Is that anything different than what I just did on the previous example? It's order of operations, right? If you think about it, why would I multiply before I add? Order of operations says I multiply before I add, right? I drink water. Because usually they don't have a lemonade. If there's a lemonade, I'm a lemonade guy. I do water my lemonade. I take my 20 ouncer and make it a 40 ouncer. I do the exact same. I'm with you. Like lemonade way too. I'm not going to do this one for right now. I guess I could. Let's do it. What the hell? Sorry guys. It's just me. Love me. Okay? I love you for who you are. Even if you listen to music while I teach, I still like you. I might get frustrated. You might get frustrated if I swear. It's all the same deal. Okay? Your music swears. Maybe it doesn't. The mocap doesn't, so okay. Okay. I am of this faith, but I don't really care if you are or not. Doesn't hurt my feelings if you're not. But if you've noticed, sure, they've been asking us not to say LDS or Mormon anymore, right? What are we going to call the Mormon Tabernacle Church? Choir. The choir. Ooh, okay, so that somebody's actually answering my question. Hey! Because I always thought that was funny. I'm like, no, anyway, I'll shut up. Offer religion. All you want. Worship anything you want. To be a cow for all it's things. Up to you guys. I think, isn't there like a religion that thinks cows are holy or something? Maybe. I think so. Because I watched it on. I know this is not very great, and this is my resource. It's off of planes, and then they go into India spot or whatever, and they have to worship. I'll shut up. They're worshiping those attractors. Because I just plot the points that they have on it. See, this is 0, 2.
So it's not.
It's the order from left to right for me. Okay, so what does this do? Shifts us which way? Right. 3. So is that the x's or the y? X's. So notice that would be 3, 2, 4, 0, 7, 3, 8, -1. Order of operations says I would do this now, right? And basically, once again, guys, I'm looking from this function to this function. What's different? We've already shifted it, haven't we? So I don't need to go back to the parent and shift it and then multiply by 2. I just need to say, what's the previous one look like and what am I doing now? So that 2 is the thing that's different. Do you guys agree? You guys see how I'm doing step by step as well? Okay, multiplying by 2. So is that the x's or the y? Y. Because it's outside my function. You might want to write that in your notes. Anything on the inside of your function, deals with your x value. Anything on the outside of your function deals with your y value. You were all nervous. So this is 3, 4, 7, 8, but this becomes what? 4, 12, 6, -2. Oh, that's a 0? That looks like a 6. I messed up. Ah! Better? Thank you. What's our last thing we do? Notice we looked from the previous example to this example. What's the difference? They're +1, so we're going to drive it up 1. Is that our x values or our y values? If we're going up 1. Y, right? You sure good? Okay, make sense? I'm going to plot these points now. You guys have them for me, though? So I have 3, 5, 4, 1, 7, you said? 7. Yeah! When your mom says no, you're going to run. Orthodontist or run. Am I right on the one? I take leftovers. Where are you going? That's right. Going to Wendy's number 2, no ketchup. Biggie size is all right with me. All right, I'm just saying, I'm just telling you other choices. Cafe Rio, do the special of the day, fine, whatever. How are we doing, Julie? So this is a lot of, right there on a 1 to 10 scale, the very first one was a 1. We shifted it. Very rigid, not very hard, right? This is more like a 4. Was this very hard? You guys want to get a 10 out of 10? We'll go with 8 first. How about that? We'll do an 8. What function do you want? Brady, what function do you want? Cubic. Okay, you want the cubic. All right, here we go, cubic. Actually, we'll just do it very nice. This will be about 6. That is -1/3 x raised all to the cube. Okay. Does this shift left or right? Jeremy? No. Why does this not shift left or right? What value makes that 0 still? Still 0, right? that make sense to everybody? What value makes this original guy 0? 0. But if I times by something, does that change it? Value of 0? So does he shift? Everybody with me on there? Is this inside or outside of our function? Is that our x's or our y's? X's, okay? X's. So my question is, here's my parent function. Oh, crap. Well, we just made it a cubic function. Because I don't want to change those numbers. The cube root of x. Oh, I love you all. Thanks for being with me. Does everybody understand why I wanted to change it? Because I did my long exercise. Friends like Mr. Roberts, you're just lazy. You can say it, Brand. Just say it. What we're going to learn. Is it a stretch? Why is it a stretch that you're saying? You might be right, but why is it? If you believe. What did Miss, what's her bucket, Burton say to you about this? Why is it a stretch? You're right. I just want to know why. Okay, so it is going to be, what if it's a shrink? Since it's a third, why would it not shrink us? You said stretch, so I want to know why it's a stretch and not a shrink. Stretch is correct. Go ahead, Cosette.
There's a violence effect over there. If you change something by to make it zero, you like 1 or whatever, you would have to stop.
Okay, I like that answer. It's a little confusing, but I know what you meant. Okay, so what she's saying here is because I'm timesing by -1/3, but just like in my previous example, right? My question here on this step is, notice I want to get back to this same y value, correct? So if I shift it right 3, that gets me back to that same y value. You guys agree with me on that? Okay, so when I look at this, what x value gets me back to taking a cube root of a number to give me -2? So basically I'm saying, oh, -1/3 x, how am I going to get back to being 8? Right? Because that was my, excuse me, -8, because that was my original x value. You guys agree with that? Is that kind of what you're saying, Cosette? How do I get rid of times it? So x is 24. Notice I just had to stretch my x values, which you were right, Daniel. But what's stretching my x value? Because notice instead of being at 8, I'm at 24. Now notice I flipped from this side to this side because there was a reflection as well, right? So vertical stretch and a reflection. If it was just 1/3, that would stretch me. Correct? Instead of being at 8, I'm at 24. Did you see how this is stretch? Yes? What if that was a 3? What would it be? Shrink, because I have to cut everything in 1/3. Let me explain the reason why. Because once again, I'm trying to get back to my main x value, right? So I'm asking myself, a -1/3 times what gets me back to -8? It's going to take a larger value, isn't it, to get me back to -8? Hence why we're stretching. Okay. Not necessarily fraction, because 3/2, that's a stretch. I mean, excuse me, 3/2 is shrink. There, that's a better definition. Or do we have to say a fraction? So we just say a number less than 1, right? If it's a number less than 1, that will be a stretch. If it's a number larger than 1, it'll technically be a shrink, which is kind of opposite in our head, huh? But notice, if we think about it, basically everything on the inside is opposite of what we do anyway. We saw a +3, which way did we move? We went left. We say a -3, which way did we move? We went right. Kind of opposite anyway, right? See what I'm saying by that? Okay, so I'd have 24. I'd have 3. I'd have 0. I'd -3 and -24. If you don't believe me, watch what happens. -24 times -1/3. That gives me 8, doesn't it? 8, the cube root of 8 gives me what? 2. Right? You can always check to See if you get back to the same result. Okay. Yes, ma'am.
I don't know about this, so it's like,
Go for it. I'll try my best to.
okay, so it's like the number that we're using is less than minus expected. So does
Yep.
that
So
mean-
for example, if I had the absolute value of that number times x, right? Because -5, right, is a number less than 1, but no, that would still, that's actually a shrink. So I should say the absolute value of x that's between 1 and -1. Does that make sense? Like, you want this number to be basically less than 1, but greater than -1. If that still stretches it, right? That would be a shrink. Because what is the negative doing? The negative is doing this. Here's our graph. Let's say it's a quadratic. Our negative just flips us that way, flips us over the y-axis. So we have, in this case, a cube root. I don't know. Do you guys even know what a cube root looks like? With plotting those points. Here's what it looks like in the parent. So I kind of think of it as almost like an Egyptian, right? Okay, so we're there, but then if I have just a cube root of -x, it just reflects, right? It's the same graph, it just reflected over the y-axis. Now, what if I had negative cube root of x? Here, what does that do? Is that reflected over the x-axis? We're taking stuff that was positive and making it negative, stuff that was negative, flipping them up positive. With me? Okay. All right. So here's my parent function. What would this guy look like? Oh, well, here's at -2 was at only at 8, but now I'm all the way down here to get that same point. So hence why we're stretching. Does that make sense? So here's it was at just -1. Oh, excuse me, 24 -2 down. So it's just a lot. Yeah, that looks horrible, but you get the idea if you plotted one. And all you guys should be able to plot points, my fourth graders plotting points. If you're not, I believe in you anyway. Okay, with me? Should we do a 10 out of 10? Should we go for it? Ready to rock and roll? Which function do you want, James? You tell me. Quadratic? Oh, hold on. There we go. Oh, have we dropped yet or only raised? We've only raised. There we go. Okay, this is the hardest thing you'll see. Now, is there any difference between a quadratic, a cubic, a square root, or any of the different parent functions on the hardness of this? No. Every parent function. How many parent functions did I just list for you guys? 6, right? How many will you guys have by the end of the year, do you think? 15 parent functions. But even when I ask you to graph trig function, okay, is the steps any different? They're not. They're the same item. It's just a different parent function, meaning the way it ends depends on where it starts, right? You're not going to have a cubic from a quadratic, are you? No, it's still going to look like a parabola. It's just different types of parabolas. It could be just shifting left and down. We could be up and down. We can make it steeper. We can make it wider, right? We can flip it. Does that make sense? They're all using a quadratic. It's just what's happening in the shifting and the transformation. Right? Okay, here we go. Step 1. Who do we start with? Not yet. We're going to start with our parent function. You got to have a starting point, right? Is this how I want you guys to do it on a test? Yes. I want to see you understand what's happening. Hey, am I going to let you use your calculator on this? Cosette? No. Okay. And if all of a sudden I have no work and you get the right graph, do you really think I can do it? No. Okay. All right. Now what do you think we're going to do add? And why do you do the negative 3x and not the shift first? Order of operations, right? Everybody there with me? Any questions there? Okay, here we go. So what is that going to do to all my x values? I'm going to multiply them by what? Not negative 3. Negative 1/3. Once again, if I multiply him by negative 3, okay, just like you said, that means he's 6. So if I plug in 6, 6 times negative 3 is negative 18. Does that give me back to 4? No, remember, you just multiplied by it, so you're cutting the x values that you originally had in a third to make sure that they are getting us back to the 4. What is that called, by the way? What did we just do? Can anybody tell us what in words what we just did? We did a horizontal shrink. We haven't shifted yet. We did a horizontal shrink. Notice we had larger numbers and we just made them smaller, didn't we? We went from negative 2 to 2/3. Are we ready to walk?
I'm walking.
Okay. You guys keep working on this. Okay, I know you guys don't get the great view, but it is what it is. Oh, that's nasty. Okay, so what's next? Actually, you guys wouldn't know. Hopefully you guys got this right, because that's the tricky part on the next part. You guys ready? What value makes him 0? How many of you guys shifted to the left 6? Raise your hand. How many are shifting to? Yeah. How many? Really? How many of you guys went to the? Sorry. Yes. Yes. Because once again, what's the definition? Why do we shift the way we do? Is negative 6 the value that makes this guy 0? Because wasn't that our definition of why we're shifting the way we do? It's not 3. 2. Okay. Here's my reasoning. Okay. So watch the reasoning behind this. Okay. Here's our reasoning. You guys tell me, is this the same? Is this equivalent? What value makes that 0 very easily? And which way we need to shift? We need to shift right. That's the tricky part. Okay? So, I apologize, that's the one I left you guys on. Okay? So, that's 8/3. Yay, he's fun, huh? That is 7/3, 0, 5/3, and 4/3. Should give us, oh, I just finished this up. Anybody believe me? Now, if you did that other one, how could you tell that your answer was not right if you shifted them to the other way by -6? I could plug one of those results in, huh? So we check, anybody, Anna, tell me one of those results to plug in. Huh? 8/3, she said. 8/3 minus 2 is 2/3. 2/3, negative 2/3, excuse me, no, it is 2/3. 2/3 times negative 3 is what? Negative 2. Oh, look, there's that 2. Negative 2 squared gives me. Does everybody understand why we're shifting to the right 2? Because once again, that's the value that makes it 0. Yes, sir? Why does 0 stay 0? Because once again, did I not move him? Oh, I forgot to move him. He would just be 2. I apologize. Thank you, Brady. Because that's 6. I shouldn't. I'm like, oh, no, that's not right. Thank you. Okay. So now I have negative 2, and notice because I've already did the shift, I'm going to come back to this guy. Huh? Multiply by negative 2. This one's on the outside. Outside, you do exactly what it tells you to do. And here's the reasoning. Because just as I said, I put 8/3 in, right? I did 8/3 minus 2, which is 2/3. Okay? I do 2/3 times -3, which gives me -2. -2 squared gives me 4. Now I'm at 4 times -2, which gives me -8. You guys see how all it's doing is if you follow it piece by piece, it'll take you like here, the x's, it'll take you back each step, right? Then it does the function, it gets you here. That's what's coming out of the function. Then you're timing that by -2. Then what are we going to do after that? I know we don't have it yet, but we're going to drop it like cotton down. Okay? So these x values stay the same. But I'm going to times everything by -2. In reality, let me just show you what just happened, okay? Here's our very first function, x squared. What does -3 inside of x squared look like? It looks like this. I had to rotate because of the reflection, right? But I technically, it looks like a vertical stretch, but I'm horizontally shrinking, right? Okay, so I've done that. Now I need to shift right 2. That's what I've done with me. Then what does that -2 do? Well, the 2 stretches me taller. What does the negative do? Flips me down, right? That's why I'm down here. Does that make sense? I made those very large values just negative. That's why I'm down. Then what is it going to do? Drop us 4 down. So if I drop us 4 down, I'm just going to write this right below just for the fact. So that'd be -12, -6, -4, -6, and -12. Okay? None, I don't think. By the way, this was actually not too bad. Oh, that sucks. Okay, so if I plotted that, I had 8/3, right? Correct? 8/3. Was that -12? What was another number? 7/3 was what? -6. -2. 2 was at -4. 4/3. 5/3. -6, and then boom. Okay. It looks kind of daunting, but if you take it a piece by piece, it's really not too hard. Okay? And it's really just saying, what's happening here? So really quickly, I want you guys to build a function if I tell you all its transformation. I want you to use an x cubed graph. Okay? Let's say I tell you it went right 4, up to, reflect about x-axis, and vertical stretch of a half. Not -1/2, a half. How would I write that? Reflect about the x-axis. So here we go. We got an x cubed. How do we do a right fourth? X minus 4th, right? Okay, up 2 plus 2 on the outside. Reflect about the x-axis. Is that the inside or the outside? So notice what's happening. Is it my y values or my x values? If I'm reflecting about the x-axis, that's doing this, correct? So that just is your y values. Is that inside or outside? Outside. So it's negative on the outside. Is there a number that's, well, I should say a shrink there instead of a stretch, huh? So a shrink of a half. So we went from here to here. X or y. Y, is that inside or outside? Outside, so I have -1/2 y. Okay? What would be a negative on the inside to reflect about the y-axis? Right? Inside is the x's, but notice watch. I'm taking values that are positive, and if I multiply those positive values, meaning that's positive, right? We're going in the positive x direction. If I multiply these values of x's that are positive by a negative, where does it go? I just rotate these up and fly it. Make sense? And so it was like a horizontal stretch of 1/2. The half would go like 1/2 x. It would not be 1/2 x. It would be 2x. If it's a horizontal, remember you got to do opposite. So they said it was a horizontal shrink of 3, not 3, horizontal shrink of a third. What's the value inside the parentheses? 3. And then I'd go with my shift, x minus 4. And then squared. So you could have 3x minus like this, or you could have okay. There's one other thing on there, but I think you guys already know how to do this. I'm going to hurry and just do it though. Hold on. All right, so we're just going to solve. How do I get rid of the -1? Add it. How do I get rid of the -2? Divide it. So I'm at x minus 3 cubed equals adding 1. Sorry, I want this to be a +1. Subtracting 1. -16 divided by -2. 8. Take the cube root. 2. It's not plus or minus though, because it's a cube root. It's an odd root. It's not an even root. So odd roots can be negative or positive, so they just come out the way they are. X is 5. Okay? Thanks, guys. Have a good one. Isn't that us? That's us, right? Yeah. Hey, I really appreciate you guys sticking with me there. Thank you.